Okay, here we got it. This has been a while. Have been several months since I picked it out to check it, but a lot of things got more interesting. So what we're going to do is to check what's wrong with this one. I have not the slightest idea. So what we're going to do first is to power it up and see if everything got some electric energy. Okay, I'm going to use this what's it called? It's a kind of a transformer. It's a variable, so I can decide myself how much energy I want to use for this. But before I connect anything, we need to check the voltage so we don't overpower the amplifier. I don't want that. Voltage AC. Make it so we can see anything and power up. 82. Close enough. Okay. That on. So what we're going to check now? Well, I'm going to check if it has any kind of electricity on the boards. Okay, then we power up and see what happened. Now this one is what we call hot. Don't touch too much. So what we're going to do now is to check, is it on? Yes, you see that that green light? That tells me that the low voltage from the power is okay. So what you're going to do now is going to test call it a high power, high voltage, which support the main amplifier. So we take the mighty meter. What do you think it is? Is it what kind of voltage? Is it AC or is it DC? To make it very short, if you feed any kind of electronics with AC, then you will send smoke signals. Main electronic components cannot manage AC. So I'm going to measure volt DC. And this one going to be a little sketchy because I really don't know. I think I do like this. One down there and one down there. .6 volts. Well, I know for sure that 8.6 volts is absolutely not enough to power a sub bass amplifier like this one. So I think we found what's wrong. The main problem for this amplifier is in the power. as I can see it from now. So let's dig in. Okay, let's see. Clean up a little so we can see what we are doing. We need to take this card out. It's going to be a challenge, as I can see. Oh, okay. What's that? No, it's not. Why I use this one is because this, what you call it, this connector, it has a lock. So if you try to pull it out, you will probably destroy it. So what you're going to do is use a nibbler and you press it like that and you just pull it off. Minus this one going to be a little tricky. Oh, wasn't that tricky? Everything disconnected? Yes. Okay. It is a problem starting to get my age. My eyes is too weak on the distance. Works close, but something in between. I'm too close to use the glasses. I'm too far away not to use the glasses. That's a little problem. Well. There. A box like this is always nice to have when you are trying to fix anything, because you can put everything you you take out, like screws, or I have something screws only. Here I have the shell to the turntable I'm trying to fix, and so on. So, okay. So the first thing I'm going to do is to check if I can see anything, to see any burns, or see if it has been a little hot somewhere. What I can see is that someone has been here before. And that is not always a good sign. Seems okay. And from this end, capacitors seems okay. Yes. Okay. As you can see, it's no visual. So then I'm quite sure it is not any capacitors or resistors which is the problem. It's more like, most likely, a discrete problem. It means like it is probably some diodes or transistors which is the problem. Okay. And what I thought was transistors is not. That's cool. Okay. The mighty multimeter again. And we're going to have some diode check. As we understood, this one had no problem, which means this small signal voltage has no problems. It is the high voltage which was the problem. So I'm going to just to check, just for fun. I'm going to check. I think like that you will see anything. So I'm going to check these diodes, which is, you can see them under there. I'm going to check, let's see. Okay. Can anyone tell me what the heck is this? I have to take off this clip so I can see what is this component. I have a bad feeling about that one. IRF 540. This transistor is a MOS transistor, so I have a little hustle to test it with my multimeter. So I'm going to, I have one there, some funny little thing, but it is, it's not much room to reach. I have this, but well, I can. I have this as well. Is it possible to use these ones just to oh, my fingers are starting to get too big. One. sorry if you cannot see anything, but I find it more important for me to see. So I'll let you have a look after I've been placing all these pins, needles and pins. Wasn't that smoky sometimes in the between 70s and 80s? There, one more. Oh, come on, like that. One, two, three, two. There. Okay. Let's have a look. Testing. Two diodes. 3.63 and 2.51. That is not what I expected for a MOSFET. We're going to investigate that one a little more. Well, I was, as you could see, this one was observing that MOSFET as a double diode, which is not. So I was thinking it's not supposed to do like that. I have a MOSFET here. It is a logic gate MOSFET, but still it is a MOSFET. So I'm going to test just to make sure that I'm not thinking wrong. It's funny every time I'm thinking wrong. But I find it most fun when I'm not thinking wrong. Yeah, do it like this, easier. Okay, and we test. Bingo. Here we got it. This is the way a FET transistor will appear, like that. This will measure out like a double diode. So what we're going to do is we're going to literally take it out and test it again. But then I need to clean the table first. Okay, so what we're going to do is we're going to desolder that one, and then we need the mighty soldering iron. And we need this one and this one. There. Well, I have certainly try again. There you go. Absolutely nothing wrong with that one. Okay. He got fooled. So this one is not needed to replace. So this one is going back again. We're going to check these others. We have some more diodes. We're testing with this one. So we have one there. That one was okay. And that one is okay. Okay. So, in other words, there's nothing wrong on this side. Well, it can be some other transistors here. Of course, we can test them just to make sure. Just to be sure. Okay. Okay. That was not the transistor, it is that one. That one is okay. And we have one there. Those three is okay. Okay. Another MOSFET. Okay. I really need to take out this one to test it. God, I cannot reach it. Okay. Well, this is for certain not correct. Test again. There. That was a little bad contact. Yeah. Okay. So, nothing wrong. Somehow, it's cool when it's not anything wrong, but somehow, in another way, it's frustrating. So, place them again. And we search for errors somewhere else. Okay. So what? Well, it is nothing on this side which is the reason for the voltage to drop to like 8 volt. I could understand it if it was like 80 volt, but 8 volt does not make sense at all. As I can see it, there's nothing wrong with the power handling. There's nothing wrong with any kind of transistors. It's nothing wrong with the FET. It's nothing wrong with the diodes. And as I can see, no resistors is burned or anything. So what I think it can be, and this one, to tell it a little, this power is digitally switched, and if the switching frequency is too high or too low, it will affect the output voltage. And as I cannot see any place on this board any kind of switching devices, but that one, that card, I cannot see what it is. So it seems like it all burned down to one thing, and it's that card there, because I cannot see anything wrong anywhere else. But to find that one, well, we can try. I can try to Google it, but that will be for eventually some other episode.